Hey everybody, so in today's workout, I'll be reviewing respiratory physiology and discussing how the respiratory system responds to exercise by increasing ventilation and delivering oxygen to the body. The respiratory system works closely with the circulatory system, so you'll hear a lot of repeated terms and kind of concepts from last videos, but ultimately kind of ensures that oxygen is delivered to the working muscles while carbon dioxide produced during metabolism is removed. As I begin exercising on the elliptical, my muscles immediately require more ATP to produce movement, and since aerobic metabolism depends on oxygen, my breathing rate will begin to increase in order to meet this demand. This process of moving air into and out of the lungs is called pulmonary ventilation, and ventilation consists of two phases: inspiration, when air enters the lungs, and expiration, when air leaves the lungs. During inspiration, the diaphragm contracts and moves downward, while external intercostal muscles expand the rib cage, thus increasing the volume of the thoracic cavity, causing air to flow into the lungs. During expiration, at rest, the diaphragm relaxes and air is expelled from the lungs. And as exercise intensity increases, expiration becomes more forceful, allowing carbon dioxide to be removed more efficiently. Air is going to travel through the nose and mouth and pass through the pharynx and larynx, and then continue down to the trachea, where it then enters to the bronchi before reaching the bronchioles and finally the alveoli. Now that we've transitioned into the workload with walking lunges, my breathing is going to become deeper and faster. And there's two important measurements of breathing, which is respiratory rate and tidal volume. Respiratory rate is, the number of breaths taken each minute, while tidal volume is the amount of air moved with each normal breath. During exercise, both respiratory rate and tidal volume will increase, and together they determine minute ventilation, which is the total volume of air moved into and out of the lungs each minute. As exercise intensity continues to rise, minute ventilation increases significantly, so the body can continue delivering oxygen and remove carbon dioxide. This is why breathing becomes noticeably heavier during more intense exercises. Now here in a second, when we transition into a walking recovery, my breathing rate will gradually begin returning towards resting levels, and although the exercise has stopped, my body still requires additional oxygen in order to help restore normal physiological conditions. Ventilation remains elevated for a short period for a short period as oxygen continues to support recovery and carbon dioxide is removed from the body. Ultimately, this demonstrates how closely the respiratory system responds to changes in exercise intensity. And just to kind of summarize everything, the respiratory system is going to provide oxygen for aerobic metabolism and remove carbon dioxide produced during exercise, while pulmonary ventilation, is also going to increase through changes in respiratory rate and tidal volume, allowing the body to meet increased oxygen demands of physical activity. And these responses are essential for maintaining exercise performance and supporting recovery once exercise is complete.